all of we know that the digital computers use the binary number system to represent all type of information inside the computer, and also the alphanumeric characters are represented using the binary bits, that means 0 and 1. Now digital representation are easier to design and storage is easy. Accuracy and precision is also greater. In spite of that, there are different type of number representation technique. For example, binary number system, octal number system, decimal number system, hexadecimal number system, but the binary number system is more relevant and popular for representing numbers in digital computers. Now today in this lecture we will discuss the two basic representation of number system in relation with the computer architecture. And first point is that I have written down here that the fixed point representation, and second one is the floating point representation. Now first we will discuss what is fixed point representation. Now in this representation has fixed number of bits for integer part and the fractional part. All of you know that the number can be represented like this is, suppose this is your decimal number. So you can say that this number has a integer part and also has a fractional part. Now in the fixed point representation, and also the sign of the number is also important, where the sign may be positive or may be negative. Now in the fixed point representation we have fixed number of bits reserved for this fixed point integer part, and fixed number of bit is reserved to represent this fractional part. So that is the fixed point representation, and I am just using and also fixed point representation. In the case of the sign fixed point representation, there are three fields. First field is your sign field, sign bit field. Second one is your integer, and third one is your fraction. To represent a number, the signed fixed point number in a computer system, we require this. Some bit is reserved for the signed representation. That means only one bit we require in general case. That means if the number is positive we represent with a 0, and number is negative we represent with a 1. That means only one bit is required. And in the case of the depending upon the computer system, we have reserved the different bit or the storage. That means in the fixed point representation we are fixing the how many bits are, suppose we have fixed that the 5 bits are reserved to represent this integer part, and 10 bits are used to represent this fractional part. So this is fixed throughout the any number system, or the any number that will be represented by this fixed point representation. Now I will like to give an example by which you can easily identify how this fixed point number is represented using this three field. And first field is your sign field, and second field is your integer field, and third one is your fractional part. Okay, so suppose this is a number. I am going to represent the number in a 32-bit format. So the example is, assume the number is 32-bit format. Okay, we have assumed the number is 32-bit format, and we reserved 1 bit for sign. I have already said that we only require 1 bit for sign, and 15 and this representation is using 15 bit for integer part and 16 bit for fractional part. Okay, 16 bit for fractional part and 15 bit for integer part. So that is the question. A number, assume a number using a 32-bit format. We are using the 32-bit format, and out of the 32 format, 1 bit is reserved for sign bit, 15 bit is reserved for integer bit, and 16 bit is reserved for fractional bit. Now the number is, suppose the number I have assumed is that 43.625. So that is the decimal number, and you have to represent this decimal number through the fixed point representation by this format: sign, integer, and the fraction. So we have to represent this decimal number, sign decimal number, into binary number, obviously we have to convert it to binary, and the different bit pattern is 1 bit is reserved for sign bit, 15 bit is for integer, this is integer and this is fractional part. So how do you represent this? So we have to make sure that this bit is 0, this bit is this bit is not 0, and this number is negative, so sign bit is 1. So that is for the case of the sign bit. Next we have to know that in the question it is said that the 15 bit is reserved for the integer part. So we have to first convert the 43 into its corresponding binary format and then represent this binary number in the 15 bit number format. So 43 is just the binary of 101011. So 43 binary, you can get this, the 43 binary is 101011. So 1 2 3 4 5 6. So apart from the 6 number is there, so 1 2 3 4 5 6 7 8 9. So after 9 0, okay, so 1 2 3 4 5 6 7 8 9. So after 9 0, this is the 9 0, and 43 binary is written 1 0 1 0 1 1. Okay, so this is the representation for the, this is 1 minute, this is the representation for the integer. Okay, and we have here used 15 bit, we are here used 15 bit. Okay, and 1 bit is already previously reserved for the sign bit. And next 0.625 points, if you just convert 0.625 into binary, so 0.625 is equivalent to 101. So 0.101 is 0.625. okay, so 0.01 is 0.625, but at the fraction part is there, so we have to add in the case of the 43 we can use as many zeros before the number, so that does not affect, because this is before the decimal. And so after the decimal, suppose we have to represent a number 0.15, so if we just add as many zeros after that, it will not affect. Like if the number is 15, so we can use as many number before that, so it will not affect the number. So that concept we have used. So after the fractional part we can use as many zeros after that, and for the integer case we have used as many zeros before that. So that concept is actually used. So we have to represent 0.625. okay, so 0.625 is 0.101, and we have also reserved the 16 bit for that. So that's why 0.625 is nothing but 0.101. This is 3 bit, and after that we have to use 13 zeros. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12 13. Okay, so this is the total representation. This is the representation for the sign bit, fractional part, and this is the representation for the sign part, and this is the representation for the integer part. So if we put all the number point after that, this number, so this is the total representation of minus 43.625 in an fixed point representation. So from there you can easily identify the disadvantage of this. The disadvantage of this number is this type of number system, or the representation of this type of number system, is that we have to only use the limited number of number to represent, because if the number integer part number is such a binary number which is exceeding the 1, all of the 1, suppose all of the 1 has been represented by this, and we have to represent the number greater than that, we cannot represent this number. This is the disadvantage. And also another more disadvantage is that it is the representation is the cubous sum. It just looks the cubous sum, so it does not allow the enough number and the accuracy. A number whose representation exceeds the 32 bit have to be stored inexactly. We cannot store the number. Okay, so that is the use of this And also the smallest number that is can be represented by this representation is in the for the fractional part you can represent 2 to the power minus 16. 2 to the power minus 16 is nothing but 0.000015. that is the smallest number you can represent with the help of this number system, and that number system is so much of disadvantage. So to overcome these disadvantages or all of the disadvantages, we are just using the floating point representation. In the floating point representation, suppose this is the number, I'm just giving you overview what is floating point representation. Suppose this is the number 43 point, what is the number 43.625. so if this is the number, so we can represent in the case of this radix, this is the radix of the decimal point, okay, and this is the integer part and this is the fractional part. But in the case of the fixed point representation, this is fixed, okay, but in the floating point representation we can move the radix point anywhere we want. That means suppose this is 0.43625 into 10 to the power 2. so in this is the, if this is the representation, this is called the floating point. And also we can also represent the number 0.4 sorry 4.3625 into 10 to the power 1. so if this is the case, that means the number radix point is moving anywhere. So if this is the case, radix point is not fixed, so this is called the floating point representation. And in the case of the floating point representation, in the coming lecture we can see that this has got so many advantages, and also this representation is nowadays are valid. If you want to represent any number in the computer system, then this representation is quite popular, okay. So as I have said that in the case of the floating point representation, we can just represent this number like in this way, also in this way, like 0.43 into 625 into 10 to the power 2, 4.3625 into 10 to the power 1, like this. That means this radix point, this is called the radix point. This radix point can be movable in the left or the right. We can move it according to our wish, okay. So that is the meaning of the floating point representation, and that is this radix point is fixed in the case of the fixed point representation. Now this is the formal definition of the fixed point representation, that the fixed point representation has fixed number of bits, okay, and for integer and part and for the fractional part, okay. That means it has a fixed number of bits for this integer part and a fixed number of bits for this fractional part. That is the fixed point representation. And for the floating point representation, this is the formal definition. So floating point refers to the fact that the number that a number's radix point can float, it can be placed anywhere relative to the significant digits. So at the definition says that we can move this radix point to the right hand side also or to the left hand side also, then this exponent is actually changes, okay. So that is the definition of the floating point. Next, in the floating point representation, we will see some of the example that how floating point can be represented. Suppose in the simplest case, floating point can be represented like this. Suppose the number is 101 into 0.1. This is the number, and we want to we can express this like this way, 1011, because this radix point can be movable. So we can represent this like this. So this is your integer part, and or called the mantissa part, and this is also called the exponent part. And here this is 0, so sign bit is, this is for the sign bit, that is mantissa, and this is exponent, okay. So bits are reserved for the signed and also exponent and also for the mantissa. So suppose we have some number of bit associated with, that means 1 bit is reserved for sign bit, 4 bit is reserved for exponent, 5 bit is reserved for mantissa. In this way it is represented. Number is not directly represented, but it is represented in terms of sign, exponent and mantissa. So at the case as the number is positive, so we can case that the sign bit is 0. So in the case of the exponent it is 3, so we can represent here the 3 like this way. And for the case of the mantissa, so 1011, so 10 this is 5, so 1011, and you can put at the number of zeros because after the After the point, this is the fractional part, as I have said that if the number is 0.625 or like that, we can add as many as 0 after that. It will not affect anything like this. So this is the case, we can add 0, as this is the 5 bit, so 1011 is for the mantissa part, and we can add 0 at the right hand side because it does not change the number, as this is the 5 bits reserve. That's why we are represented like this. This is for exponent part and this is for the sign bit. Okay, so this is the formal representation of a floating point representation. Okay.